Hello and welcome. Today we're going to listen to a video not about Distribution Ninja. We're going to have a video about polynomials. I'm making this as a kind of review. We do have a quiz coming up tomorrow and we have a test next week. So I just made this not as a required video to watch, but as a video that you can just kind of watch when you want to review, maybe, I don't know, just quickly kind of warm up and remind yourself of what we need to know. Alright, so the first thing you're going to need to know is how to classify and find the degree of a polynomial. First example is up there. Now the classification, again, what you want to do with this is you're looking for how many terms there are, and terms are always separated by subtraction or addition signs there. So what that leaves us with is 1, 2, 3 terms, which is, of course, a trinomial. You guys have been pretty good about that, so I don't know if that's how much you need to study, but degree, some people still are kind of mixing it up. So if you're finding the degree of a whole polynomial, you have to look at each individual monomial. So I'm going to break these into 3 separate monomials. And to find the degree of each monomial, we need to add up all the exponents of the variables. So in my first, I have x has an exponent of 2. Y doesn't have anything, but when we don't have an exponent there, we can add in a 1. It's kind of like the invisible 1. And then z has 3. So within each monomial, we'll add up all those exponents. So 2 plus 1 is 3 plus 3. This monomial has a degree of 6. Over here, only I have a variable 4, so the degree of that is 4, and the last one, the degree is 2. I know my handwriting doesn't look great. I'm writing on a screen, so give me a break. So finally, to find the degree of this whole polynomial, we take whichever one is the highest, and it looks to me like our highest is 6, so the degree of this trinomial is 6. Okay, the next skill we need to know how to do is how do we add polynomials. Okay, what you need to remember about adding polynomials, 1, the exponents aren't going to change. And the reason why they're not going to change is because we're just looking to combine like terms. And now, when we did the subtraction, I know a lot of people wanted to distribute the minus sign in between the two parentheses, and you technically could distribute a plus sign, but it just doesn't change anything. So when you're adding polynomials, we can ignore all the parentheses and just combine like terms. So I'm going to mark my like terms here. I have an x squared and an x squared. We're going to combine those like terms. And then I have 7 and negative 11. Those are like terms, but they're not the same as anything with the x squared because they're just numbers. So I'll keep them separate, and I'm marking that with a double underline. Okay, now let's just combine like terms. So I have 14x squared plus 9x squared. That would give me 23x squared. Now remember, exponents don't change when we're combining like terms. And then we have no other x terms, so I'm just going to bring that down, minus 3x. And that looks like y, but it's an x. And 7 minus 11, sign's not the same, so we subtract. That's going to be minus 4. Now that we have no more like terms, we have an x squared and an x. That's okay. They need to have the exact same variable and the same exponent. We are done. Yay! Okay, so we are done, but just a word of kind of warning. You would also expect to see this problem on the test using function notation. So this is read as f of x and g of x. And what that means is, it's just a fancy kind of algebra way of saying that these are functions, and if f of x equals this and g of x equals this, and our problem is to add f of x and g of x, we would do the exact same thing that we just did. So that algebra function notation is not anything new. So that's not anything new, it's just another way to write it. No need to worry. Subtracting polynomials. Ooh, finally. we get a chance to use our ninja skills here. Are we ready? So this minus sign in between is going to get distributed. Now, recognize the difference between when you're adding, subtracting, and multiplying. In subtracting, we're just going to distribute this minus sign to everything in parentheses with a little hua, hua. Well, that was a weird looking hua. Let's try it again. Hua and hua. All right, and when we do those huas, we distribute, everything behind it just becomes the opposite sign of what it is. So I have negative 13x to the third. The opposite of a negative 11 is a plus 11x squared. And the opposite of positive 2x is a negative 2x. And if this makes you feel better, what I'm going to do is I'm going to rewrite some of these where I'm going to line them up with the other like terms to make it a little easier to add, because we have a 4x squared and 11x squared. Easy to line up. I have a 14x squared I'm going to add here. That's positive, so I put a plus in front of it. And minus 6. So now when I combine like terms, that's easy enough. I can just add down. So nothing to do with our negative 13x to the third. 11x squared and 4x squared adds up to 15x squared. Negative 2x and 14x gives us 12x. And nothing to do with minus 6. Since these are all not like terms, we are done. Again, yay! Okay, so let's remember our rules. When adding or subtracting, when adding or subtracting polynomials, you need, oh, sorry, I thought I was going to hear my students just screaming over the internet right now. So yes, just like it's a callback, scream it. When adding or subtracting polynomials, you need like terms. And when adding or subtracting polynomials, exponents do not change. No change. And like I said, just expect to see it in function notation with that f of x and g of x. Alright, so now we're on to multiplying polynomials. And we know we are multiplying polynomials because in between there's no sign. You just have parentheses, and that means we're going to do a little bit of distributing right there. No plus signs, no minus signs. So that's your key that is multiplying. All right, ready? So we're going to start the first one with a monomial times a trinomial. What that means is a little hua, hua, hua. When I do those huas, the rule for multiplying is we're going to keep the base and add the exponents. Numbers get multiplied, coefficients here get multiplied, so 13 times 4, ooh, tricky, that's a 52. X squared times x squared, we're going to keep that base, that stays in x. And 2 plus 2 is 4. Now the y, there's no y there, so like y to the first plus times y to the 0, that does not look like a y. Stays just y. Alright, so that's our first hua. Oh goodness, 13 times 14. That is a big number. So 13 times 14 gives us 182, I promise. And x squared times x, again, if you don't have an exponent there, you can add the imaginary 1. Keep the base, x, 2 plus 1 is 3. Again, there's no y here, so y to the first times y to the 0 is just going to be a y. And then we're just going to multiply 13 by 6. That is also a big number. We get 78. X squared and y just kind of follow along. Right? So that's a monomial times a trinomial. In this case, keep the base, add the exponents. But what do we do when we have a binomial times a binomial? You ready for this? It's going to be a little hua, 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 hua. Yes, a double distribute. So let's start. I'm going to start at the top with a negative 3x times 9x. Multiply the numbers. Negative 3 times 9 is negative 27. X times x, keep the base. 1 plus 1, x squared. Okay, let me rewrite that one. X squared. All right, negative 3 times 4. That is negative 3x times 4. That's negative 12x. Whoa, why did I write 14? Let's just change that to a 12. Okay, that's a 12 for all the people at home. Let's see. Then we have 5x squared times 9x. This is the bottom hua. That's going to be 45x. Keep the base, add the exponents to the third power. Then the last one, 5x squared times 4 is 20x squared. Okay, we are almost done. Do we have any like terms out there? Yes, we do. We do. I'm going to write these in standard form with my highest exponent first. So first one we have there is 45x to the third. Okay, screen. There's a 3. Not a very pretty one, but still a 3. And then we're going to combine negative 27x squared and 20x squared. When we combine that, we're going to get negative 7x squared. Remember, when combining like terms, exponents don't change. They only change when you multiply or you hua, hua. It's the only time they change. Keep that in mind. And then the last thing we have is a minus 12x. And yay, we are done. No more like terms. Okay, so what can we remember? Alright, I want everyone screaming from the internet so loud I can hear it, even as I'm recording it. Don't think about that. Yes, it is possible. Just do it. Okay, so when multiplying polynomials, you keep the base and I think I heard add the exponents. Yes, keep the base, add the exponents. And when multiplying polynomials, exponents will change. Okay, now it's your turn. You try 4 problems for you. See what you can do. Hit pause. And then work on the problems. In a few seconds, I'm going to give away the answers, okay? Ready? Pause. Pause. Hit pause. Okay, did you hit pause? If not, numbers magically appeared. But I would like you to pause, try the problems. These are your answers. You can check. If you have any questions, bring them back to me tomorrow. We can discuss. You can work with people. Wouldn't it be nice if answers just magically popped up all the time? All right. So there's our problems. Before I sign off, we got a few shout outs to read. First shout out to Noah F. from Augustine. Ryan said hi with a smiley face. Lily says hi to Caroline. That's nice. Shout out to Kate B, Ocean C, Maddie C, and Anya M from smiley face. Shout out to Lydia and her child named Derek. Not sure what that means. Shout out to Vivi and her 4 children. Love ya from Lydia. This one just says follow me on Insta at Nicholas Grissel. I'm sorry if I'm saying your name wrong, Nick. Olivia from 4th period says hi to Sophia. Oh, and Sophia says hi to Olivia. That's nice. This one is just a ghost that says, I will find you. So beware of that. Shout out to Rhiannon and Claire. Period 6 rules. Jazz says something that I cannot read. I just really can't read it. It's too small and all the letters are not clear. This is a shout out to me. So someone wanted me to say a shout out to myself. And this one says, that one kid, Maddie, and you will get a cookie. This is not spam. Good to know it's not spam. Alright guys, so signing off. Just want you guys to know that you are important, you are cared for, and you are listened to. See ya.